2 secant squared theta. Now, little tricky here. I'm going to rewrite this as square root of 2 times secant theta. I'm just taking the root of each one. Because it's multiplication, I can do that. Square root of 2 is root 2. Square root of secant squared is just secant. All right? What now? What am I doing now?
Replace the t in the numerator.
Yeah, rewrite everything, right? Everything over here that used to have t's in it is now going to become an integral with thetas in it. The numerator is t to the 5th power. T to the 5th power. That means I need to take this, right, and raise it to the 5th power. Right? Okay, so maybe I should do that on the side over here. What happens if you take root 2 tangent theta, right, and raise it to the 5th power? Doesn't that mean you're going to take the root 2 and raise it to the 5th, and then take the tangent theta and raise it to the 5th like that? And that's root 2 times root 2, that's 5 of them, right? So think about those two together are 2, those two together are 2, and then root 2. So that's going to turn into 4 root 2. And then tangent to the 5th. So that's what's on that is what's on top. 4 root 2 tangent to the 5th theta. Questions? That's what t to the 5th is? Yeah? On the bottom, square root of t squared plus 2, what does that turn into? This right here, right? Root 2 secant theta on the bottom. Am I done? Got to get the dt in there. Do not forget the dt, right? And dt for us is this. So that's going to be tacked onto the outside there. Root 2 secant squared theta d theta. Yeah, now we clean up, right? We start cleaning up. Everyone's okay or no? Yeah. Root 2, those go away. One of these secant factors goes away. And that 4 root 2, yes?
Wouldn't you be able to take, like wouldn't it just be 4 tangent to the 5th?
If you cancel those?
Yeah.
Yes, and then you'd still have this root 2 over here. I decided to cancel these two. You could do these two, but you're still going to have that one, right? So it doesn't matter which one you cancel. I just chose that. And now this is a constant. I'm going to pull that out of the integral. Four root 2 is my constant coming out. And then we have what? The only thing left is tangent to the 5th, and then one factor of secant. Tangent to the 5th theta, secant theta, d theta. And then we go back to last class. So what do we do here when we have tangent to an odd power, secant to an odd power? Pull a tangent out. One factor of tangent is going to come out. Okay, yeah, so I think let's keep the trig sub up here because I'm going to need a triangle in a minute. So I'm going to leave that up there. But I'm going to have equals 4 root 2. All right, I'm going to peel one factor of tangent off to the side next to the secant theta. So it's going to be secant theta, tangent theta, d theta. So I'm peeling one of the tangents off. And the whole purpose of that is that this right here is the derivative of secant theta. And so now what I'm going to do is rewrite my tangent to the 4th in terms of secant, which means I'm going to have to use a Pythagorean identity. There we go. All right. How would you rewrite that tangent to the 4th? How would you do it? Secant squared theta minus 1, the whole quantity squared. Okay, so what we're doing really, a little slower here, we're doing tangent squared theta squared. That's what we're doing. Tangent to the fourth is tangent squared squared, and then we're rewriting tangent squared as secant squared theta minus 1, and then squaring it. And then that's still got next to it this secant theta tangent theta d theta. And now we do our basic U sub, right? You good, Joy? I was just going to mention how much we all enjoy this seam in the middle of the board. Right? Haven't I talked about this in here?
Yeah,
We love this.
To get the wall clock fixed. The time is not correct.
Yeah, no, that's been off.
No.
It's all right. We don't care about time in here.
Okay.
Thank you, Joy.
Thank you, everyone.
Okay, so U is secant theta, right? U is our substitution, secant theta. And then du would be secant theta, secant theta tangent theta d theta. And then you rewrite the whole integral in terms of u, right? In terms of u. So this is our second kind of substitution we made, right? We're going to get, our new integral is going to be in terms of u. And we're going to eventually need to get back to x. All right, this is equal to 4 root 2 integral. Okay, the secant's going to be replaced with u, so u squared minus 1 squared, and then the rest of that's du. So the good news is that this is pretty clean, right? U squared minus 1. This should all look familiar. If you did the homework, this should all be something that's like fair at this point. How would you do that? Expand that u squared minus 1, expand it out. And that becomes u to the fourth minus 2u squared minus 1, and then du. Yeah, plus 1, thank you, plus 1. Term by term, antiderivative. So 4 root 2, no more integral sign, 1/5 u to the fifth minus 2/3 u to the third plus u, plus some constant. All right. It's a lot of work, isn't it? We're not done, right?
No.
We're replacing all our u's now with secant theta, so now I'm here. 4 root 2 integral, no integral, sorry, I already did that. 1/5, okay, secant is going to be replaced, but it's to the 5th power, isn't it? So I'm going to write it like this, secant to the 5th theta, and then minus 2/3 secant cubed theta, and then plus secant theta again, right? And then I'm done with that, plus c. So I guess I need to know what secant theta is, huh? All right, so if I need to know what secant theta is, I'm going to go to my triangle, which I haven't drawn yet. Taking that equation up there, I'm going to divide both sides by root 2. So tangent theta is t over root 2. And then I take inverse tangent on, I'm sorry, no, I'm not trying to do that. Sorry, I'm not trying to solve for theta, right? I don't need theta. I'm going to just draw the right triangle. Theta, tangent is opposite over adjacent. Opposite over adjacent, opposite over adjacent, and then our hypotenuse we can solve for. And if you solve for, it should look familiar. It's the t squared plus 2 underneath the root. And now I can tell you what all the trig functions are. I need to know what secant is, though, right? Secant is the reciprocal of cosine. I know that cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent. How are we going to write this? 4 root 2, okay, 1/5. I need whatever secant theta is to the 5th power. So secant theta is a fraction. I'm going to write it like this. Secant is the square root of t squared plus 5 over the square root of 2.
Plus
T
2.
squared of
Why did I put 5? I know why I put 5, because there's a 5 right there. 2, thank you. Right, that's secant theta to the 5th power minus 2/3. Then secant theta again to the 3rd, and then plus secant theta again plus c. I'm going to go one more step, even though I don't necessarily need to. Where do I want to put it? I'll put it here. 4 root 2. I mean, we're done. We have an answer, right? And that's in terms of t, which is the original variable. So that is done. On a test, that's full credit, okay? But I just want to show you what can happen here. I could rewrite this as t squared plus 2 to the 5 halves. So what I'm doing there is I'm using the fact that t squared plus 2 square root means it's all that to the half, but then I'm raising it to the 5th, so it becomes 5 halves. Understand?
Yeah.
And on the bottom, what is the square root of 2 to the 5th power? Root 2 times root 2 times root 2. Didn't we do that earlier?
4.
It's 4 root 2. So this is down here, 4 root 2. And then minus 2 over 3. Now I'm going to do the next one. And I'm going to write that as t squared plus 2 to the 3 halves. And on the bottom, what's root 2 cubed? It's just 2 root 2. And then finally, plus the last one, I'll just write it as t squared plus 2 to the half. I could have left it as a square root, but in the spirit of having all these kind of be in the same format, I'm going to put this one to the half.
Could you
Yeah.
pull the root 2 out of the bottom to cancel that? Or root 2?
I'm going to distribute the 4 root 2 through now. Okay, I'm going to multiply that to here. What happens if I go there to there? The 4 root 2's cancel, so I'm just left with 1/5 t squared plus 2 to the 5 halves, right? That's what would happen if I distribute that to here, just kill off completely.
Yes.
Okay, minus, all right, let's clean this up. That and that are gone, right? And then when I distribute this through, doesn't this root 2 kill off with that root 2?
Yeah.
And what am I left with?
4 over 2.
4 over 3, 4/3. And then t squared plus 2 to the 3 halves. And then when I distribute this all the way to this one, 4 root 2, the root 2's cancel, and I'm just left with plus 4 t squared plus 2 to the half plus c. There's my answer. That's a nice, clean answer. Yes?
You said that that would be.
That's okay. On a test, because of time, we just get to that. You look in the back of the book, it might look like that. How you feeling? Yeah? I want to check one of these, but it's already 9:45. So far, we've used, which methods have we used? We've used the last one and the middle one, right?
Yeah.
We haven't done an example with the top one with a sine theta. I believe we did one last class with that, though. But I've got one here that we can use. So I'm trying to give you one example of each, all right? So you have that. And then we're going to start to turn the screws a little bit more. So how about this one? Square root of 16 minus x squared over x squared dx. When it comes to integration, all right, antiderivatives, what we're doing right now, what we're doing today, and the next section, partial fractions, are the hardest ones there are. I mean, this is it. We've reached this is the hilltop in terms of difficulty for integration, all right? Just letting you all know that's kind of a good thing. Like, I think, yes? It's not going to get worse. Partial fraction is pretty bad, though. So,
But that's not integration.
what's that?
Distant washers, but that's not integration.
That's application. That's us doing something with it. Right now, we're just learning how to do antiderivatives. This is back to Caleb's question last time. Like, you know, why are we doing this? Give me a real world, right? And we're not there yet. Yes.
One, are you gonna post what you have all the examples of?
Yeah. I mean, well, yeah, I can.
Which one is this on that?
Oh, yeah, I'm sorry. This is number 2. On the,
Oh, what was the last one we did?
hold on, let me look here. I've lost it. So last one we did was the 4th one. And now we're doing the 2nd one. So we've done the first one, we're going to do the 2nd one right now, and we're about to do the 4th one. I mean, sorry, I said that wrong. We did the first one, we're about to do the 2nd one, and we did the 4th one already. So we're doing that one. All right, so you look at it, you're like, hey, trig sub. X is? So which one are we using? First one, right? So our trig sub should be A sine theta. What's A? 4. So our trig sub should be 4 sine theta. Dx should be the derivative of that, which is 4 cosine theta d theta. And the square root of 16 minus x squared should be the square root of 16 minus, what is it? What do you get when you square x? 16 sine squared theta, right? Are you kind of getting the kind of gist? What we're doing here? Once we get to this? Yeah? Pull out something, 16. What's left in there should be a Pythagorean identity. The reason I'm guaranteed this is going to work is because that trig substitution by design makes this always turn into something nice. That's why we do it, all right? And then now this is square root of 16 cosine squared theta. That's what 1 minus sine squared theta is. And then that just turns into 4 cosine theta. So you're allowed to have that on your test, right? You're allowed to have that. That will tell you what trig sub to make. What it doesn't tell you, that didn't work. What it doesn't tell you is what the derivative is, right? It doesn't tell you this part, and it doesn't tell you this part. You have to derive that yourself. Yeah, so now we rewrite this integral. The square root on top turns into 4 cosine theta. The bottom is x squared, so you square this, you get 16, right? Sine squared theta. And then the very important dx. Do not forget the dx. That, like I said, is the biggest mistake students make. They forget the dx. So that's 4 cosine theta d theta. What? Hey, the 4's on top become 16. The 16's canceled, don't they? That's nice. Okay, so I'm left now with cosine squared theta over sine squared theta, right? D theta. And you sit there and you look at that for a little while and you're like, what am I going to do? What am I going to do? There's several paths to go from here. Here's the path I'm going to go. I'm going to rewrite this as cotangent squared theta d theta, because that's what it is, right?
Yeah.
And the reason I'm doing that is because now I have another Pythagorean identity. There was a third Pythagorean identity. Do you have a question, Javon?
No, I didn't realize that.
You sure?
Yeah.
4, like that. There's a Pythagorean identity with cotangent. What is it? Cotangent squared theta is equal to what? Cosecant squared theta minus 1. Was there a question? You got it? Yes. You do have a question.
How come you didn't cancel out the cosine?
This cosine is like over 1. This dx is always looked at as being in the numerator. Are you saying why didn't I cancel these? Yeah, no, this dx is actually up top. Okay? Always. This is always over 1. So it's up top with this cosine. So it becomes squared. All right, so using this, and again, when I'm doing this, you're like, what the hell are you doing, man? Like, why are you doing this? The reason I'm doing this is because I know what the antiderivative of cosecant theta is. I know it is. So this goes back to Cal 1. Derivative of sine is cosine. Derivative of cosine is negative sine. Derivative of tangent is secant squared. Derivative of secant is secant x tangent. What's the derivative of cosecant?
Cotangent. Negative cotangent.
No, what is it?
Are you talking about cotangent?
No, no. What's the derivative of cosecant?
Oh, cosecant.
Negative, cosecant, cotangent.
Yeah.
And what's the derivative of cotangent?
It's negative cosecant.
Negative cosecant squared. So these are things that you would have to know from the Cal 1, and now it's also in your formula sheet. Look in your formula sheets. Look at these formulas, the basic derivatives, reference page, what is this? 6. Scroll down and look at number 9. The antiderivative of cosecant squared u is negative cotangent u. How would you know that? I mean, like, how would you know to turn this into cotangent and then turn cotangent into this so that you can go to that formula and do this? How would you know that? Because you came to class, I showed it to you, and now you know, like, hey, be looking for that Pythagorean identity might show up. If this was tangent squared, I would do the same thing. Okay? If I ever get an integral with tangent squared, theta d theta, I'm rewriting that as secant squared theta minus 1 d theta. That's what I'm going to do, because that's what tangent squared theta is, right? And then now the antiderivative of each of these I can do. The antiderivative of secant squared is tangent. The antiderivative of 1 is theta. I'm doing the same thing right now, but with cotangent. Does that make sense? Do each one? So the antiderivative here is negative cotangent theta, and then minus antiderivative of 1 is theta plus c. I'm almost done. I need to know what cotangent theta is, and I need to know what theta is. So I'm going to go here. I'm going to go to my reference triangle. X over 4 is sine theta. So I need to know what theta is, right? So I may as well just do the arc sine right now. And then I'll go ahead and draw my right triangle. Sine is opposite over hypotenuse. And that means this side is 16 minus x squared. I'm ready for an answer. This integral is equal to negative. Cotangent of theta is the reciprocal of tangent. Tangent is this over this, right? So cotangent is this over this. So negative square root of 16 minus x squared over x, and then minus the theta, which is inverse sine of, I'm going to put here 1/4 x plus c, even though x over 4 is the same thing, right? That's my answer. Do you have any questions? I'm going to check this one. Okay? I'm going to check it. I'm going to go fast, though. You ready for this? I'm going to take the derivative of this. And when I take derivative of this, I better get this, right? All right, so when I take this derivative, I'm taking derivative, right? Take all this, take its derivative. What happens here is I have a negative, let's just put that negative out here, times, okay, this right here is a quotient rule. So I do derivative of the top. Derivative of the top is 1 over 2 square roots 16 minus x squared times the derivative of what's inside, negative 2x, times the bottom, which is x. Subtract from that the derivative of the bottom, which is 1, times the top, which is square root of 16 minus x squared, all over the bottom, what? Squared, okay? Then over here, minus, what's the derivative of arc sine of something? 1 over the square root of 1 minus whatever was in here squared, 1/16 x squared. That's what happens when I square that. And then times the derivative of what's in here, which is 1/4. That's my derivative. Somehow that all becomes this. So let's see. On the top here, this top right here, this minus and that minus are going to go away, right? They're going to become a plus. And then that 2 and that 2 go away, right? So I have an x squared on top of that root. X squared on top of that root. And then next to it, I have just the root, right? And then all of this is over x squared, right? Now this I'm going to write as this over 1. I'm going to get a common denominator and put those together. So I have to put the root 16 minus x squared here and the root 16 minus x squared there. And when I do that, I get this x squared up top minus these two together is 16 minus x squared, but it's subtracted. So it becomes minus 16 plus x squared, right? What am I? Oh, I have not addressed this. Sorry. I need to come back to that. I'll come back to that. This is all I'm doing right now is this right here. This should not be an equal sign because I did not include this part. All of that over the square root of 16 minus x squared, but then all of that over x squared. And then the x squareds cancel. So I get negative 16 over x squared root 16 minus x squared. That's what happens when I look at this as a fraction and then just bring it up like this. That right there is just this first piece. You all okay with that?
Because it's gonna be.
Wait a minute. Hold on. Why did I cancel that? No, wait a minute. That's not going
I
away.
think the reciprocal's gonna.
No. Hold on. That's not right. These two come together to be what? I'm going too fast. 16 minus x squared, right? And then subtracted. So this actually is not canceling. What is it? 2x squared minus 16? Thank you for catching that, Ash. I haven't checked this myself. I'm just doing it right now to see if it works. That's just this. Now, what about this over here? This one's ugly. Let's see what that is. 1 over square root of 1 minus 1 over 16x squared, and then times 1/4, right? That's what it is? How about this 4 that's here? I'm going to take that 4 and put it right in front of the root. Is that okay? Now what I'm going to do is I'm going to force the 4 into the root. When you force something into the root, it gets squared. No, it gets squared on its way in.
16.
So it becomes a 16. So when that goes in, this becomes a 16, right? And then distributes through, and that becomes that. So that's the same expression, isn't it? And aren't I taking this and subtracting it like that? These two? Yes? So this is it. What we're looking at right here. It's this minus this. So let's get a common denominator. I need x squared here, right? And when I put those together, 2x squared minus 16 minus x squared on top, and then the common denominator, which is x squared square root of 16 minus x squared. What do I get on top? X squared minus 16 over x squared square root of 16 minus x squared. Is this it? If you rationalize, I can rewrite this top as the square root of this, square root of that, Something is off with the sign. I need to take a sign out, but I'm off by a negative. Where am I off by a negative? This negative carried, right?
Wait, no, it didn't.
No, it didn't. It didn't go through there. Okay, so it's all right. I'm going too quick, but I think you can see what happens here. This is going to be, I didn't distribute that properly, so the signs are backwards. So this right here